All right, ladies and gentlemen, this is 11:14. Now, I'm going to remind you guys, I'm going to pass back your exam today. Your exam was graded. Okay, things were graded and entered in the Canvas for you. So I did pass that back. It's the usual scale that you guys have that we've worked with in the past. And then again, the 90, 80, 70, that's already in Canvas. So everything is there in Canvas for you. I will post solutions tonight when I get home for you, so you guys can verify where you went right, where you went wrong. But remember, we'll pass back your exam today, and we're going to focus today on all these topics are important in trig. We're going to focus on solving what's called trig equations. And in your book, by the way, that's 7.5. So some of you guys say, hey, where is this in our book? It's chapter 7, section 5. So ladies and gentlemen, we're going to show you how to use some of the skill sets that we've learned. Okay, so I want you guys to take a look at what you're seeing here. Now, what you're seeing is what's called a trig equation. And how do we know it's a trig equation? Yeah, like you might say, well, first of all, what does it say? Yeah, it says solve for what? Solve for theta.
So anything that has to do with theta is a trig question?
Well, no, we're going to go, that's only one part of it. There's theta. So you might say, why is this a trig equation? Well, it says, first of all, to solve, and then you have what? You have that equal. So there's two things you want to look out for. It says solve for the variable, and you have sine theta plus 1 equals 0. Okay, solve theta plus 1 equals 0. Now this is so you guys remember, this is an equation. It involves what kind of function is this? Anybody know? That's a what? That's a sine function. So that's a trig function, is that right? So we have solve. There's a trig function. This is an equation. This is known as a trigonometric equation. Okay, trigonometric equation. It has a trig function. It equals a value, and it says to solve for the variable theta. So this is a trig equation, and that's the name of this section. So trig equations, solving them are pretty important. Now, here's what I want you guys to do here, right? You're going to subtract 1 from both sides, and you say, why? We got sine theta equals -1. Notice what you just did. You solved for what? You solved for sine. So what you want to first do when they give you this, let me go back here, and I'm going to move this down. What I'll say to you, first of all, is solve for the trig function. So you always want to first solve for the trig function. And you might say, did we do that? Of course we did that, because what do you see? You see sine theta is -1. You solve for the trig function. Now, ladies and gentlemen, you might say to me, okay, what do I do next? Well, this is just like, in some ways, what you just got tested on. This is exactly what you got tested on. Because they want to know, what is theta, and what did they do here? Do you guys remember? I'm going to copy this. What is this known as? They restricted your domain. So they want answers here in the restricted domain from 0 to 2 pi. So you gotta think about it a couple of ways here. Where is theta, or I should say, yeah, theta. Where is sine theta going to be equal to -1? Anybody know? And it's over the interval of 0 to 2 pi. So all of these things that we just did, ladies and gentlemen, that you guys had a test on. I'm going to go to Desmos even. And I don't know, where's theta? Do they have theta? Oh, there we go. Here's theta. This is sine theta, by the way. And we want to know where this equals what. This is a restricted domain from 0 to 2 pi. So here's something you can think about. So the good news is, in some ways, everything that you did is back. And you say, what do you mean it's back? Yeah. This is that restricted domain from 0 to 2 pi. Where is sine theta? -1. Anybody remember? Why do we have to learn how to graph anyway? Didn't we have questions on the test about graphing? Isn't sine theta -1? Where does theta have to be? What's the value of theta? Well, this is 0. I guess we're going to go back and use red. Remember the intercepts, right? 0, pi. Isn't this pi? 2 pi. Those are the things that you were tested on. And then I think I even said, okay, here at pi over 2, you're a maximum value. We studied that. Here at what? 3 pi over 2, you're at the minimum value. So what is theta? 3 pi over what? 2. So ladies and gentlemen, you answered the question. The reality is you solved a what? A trig equation. The answer is 3 pi over 2 because you had to go back to sine theta being -1.
So to answer the question, we just look for the minimal?
Well, two things. What that is saying to you, sine theta is -1. What is the value of theta? This is what you're looking for. So they said in the instructions to solve for what? For theta. That's like saying, what is theta? And that, again, this is one way you can answer the question. Does anybody know another way to answer this question? What's another way? You guys just had a test. You learned some skills. You studied. You prepared. What's another way we can do this? Just want to put everything together here for you. If sine theta is -1, can we say theta is inverse sine of -1? Is that true? All right. So you might say, oh, we did do homework on this. This is why you do your homework. Is that true? This is why you worked on that. Now, I'm going to go to the TI here. Let's check the mode here. We are in degrees. Okay. So if I said to you, what is the inverse sine of -1? What do you end up with? What does that say? Anybody want to tell me? What is that? Okay, now let me write this down, okay? So some of you guys are going to say, hey, Mr. Judge, I know what -90 degrees really is. That's really in what? In radians. Here's my answer. Okay, you guys okay with that? Easy peasy lemon squeezy? However, I will mark it wrong on a test. You go, oh my God, Mr. Judge, you are so mean. And I'll say, I know. Why is it wrong? What was the domain they gave you? From 0 to 2 pi. Is that true? You go, wait a minute. Do I have to have an answer from 0 to 2 pi? Yes, that's the question. But my calculator is always right. And I'll say, not in this case. The calculator is wrong. So does anybody want to tell me, since you guys have some trig experience, what's really going on? What should you do? You have trig. You've been taking this course. You show up. You study. You work on your homework. You think about this. How would you fix the situation? Anybody have an idea? What's the key word I'm looking for? What is it? I'm looking for a key word to put everything together. You got to put it all together. You're going to ask, you're going to determine, I'm going to ask you, what is coterminal? Within the interval they gave you, from 0 to what? They said from 0 to 2 pi. So if you have this problem, and it's really not a problem, it's not a problem. What's the deal here? Trying to draw an arrow. Sorry, maybe it doesn't like. Okay, I'm going to do it over here. So if I said to you, hey, you might say, Mr. Judge, is your final comprehensive? Of course it is. What does that mean? You go, I have to know what coterminal to -pi/2 is? From the interval from 0 to 2 pi? Yes, how do you guys do that? They're asking from 0 to 2 pi here. What's coterminal to this -pi/2? Because remember, in order to get this answer, in order to talk about an inverse, remember, that's a different restricted domain. That's only good from -pi/2 to +pi/2. That's what your calculator uses inverse functions for. Okay? So you're going to have to be awake if you're going to use your calculator. You got to know what's coterminal to this -pi/2. So you might say, well, how do we do that? Don't you have to take that angle and then do what? Add what? 2 pi? So you say, I have to do some arithmetic? Yes. So what's -pi/2 now? Plus 2 pi. By now, we've done a lot of arithmetic like this. So what do you think you do now? You multiply top and bottom by what? by 2. And you get theta to be what? Negative pi over 2 plus 4 pi over 2. And what does that give you? 3 pi over 2. So, ladies and gentlemen, this is every gory detail. That is acceptable as an answer because 3 pi over 2 is in the interval from 0 to what? From 0 to 2 pi. Is that true? I'll say that again. Isn't 3 pi over 2 between 0 and 2 pi? So guess what, ladies and gentlemen? You're putting all of these things together to solve a trig equation. Getting a solution to an equation in trigonometry. So we studied every one of these gory details, ladies and gentlemen. We had a test on every one of these gory details. And so we're just putting it all together. There we go, solving a trig equation. What do you guys think? Said you might say, I didn't study for no reason. Of course you didn't study for no reason. Okay? This is why we actually do what? All the studying we've done. All right. Where did what? Which 2? Coterminal. Remember when you're trying to find an angle that's coterminal, you add 360? So you add 2 pi to that so that you could get an angle that's where? Between that 0 and 2 pi. Trying to find coterminal angles. So, okay. That's your trig equation, ladies and gentlemen. So we're going to immerse ourselves in solving for what? Trig equations. Okay. Now, I'm going to do something here for you guys. I'm going to change the variable. Because a lot of times, because these are equations, even though that x variable represents an angle theta, right? This is the same kind of question. And they're going to restrict your domain. They're going to say, okay, x will be between 0 and what? So it doesn't matter if it's x or theta. And you're going to see why they did, this x. However, we have to solve a trig equation. How do we know it's a trig equation? Well, the course is trigonometry. They say solve. It's an equation. And you have a trig function here. Is that right? This time the trig function is cosine. So what do you guys think you have to do to solve for cosine? Yeah, you can add 1 to both sides, right? Or move the 1 to the other side. And you get the square root of 2. Cosine x is 1. It's just 1. Sorry. We have to solve for what? Cosine. What do you guys do now? Divide by the square root of 2. So now you divide by the square root of 2. Cosine x is what? 1 over the square root of 2. So you just solve for what? Cosine. Okay, you guys okay with that? Now, there's a couple of ways we could go about this. We're going to have to be careful. We're going to have to be awake. How do you guys want to solve this? There's a couple. We got a couple of options here. Okay, you guys have had enough trigonometry to figure some of this out. In fact, these kind of questions were on your test. Is that right? So how do we figure out what is x? Does anybody remember? Well, we got to remember this. If you went to the special triangles. What's cosine? Adjacent over hypotenuse. Okay. So now you say, okay, I want to know what x is. This is a positive number. Adjacent is 1, hypotenuse is square root of 2. What special triangle is this? Yes, this is the what? 45, 45, 90 degree what? Triangle. Now that means x has to be what angle? Remember, this is the same as saying theta. 45 degrees. And you say, I know what 45 degrees as a radian measure is pi over 4. And you're right. So you have your answers here. However, what did they say originally? You need to find answers that are what? In between 0 and what? 2 pi. So the thing about this is cosine is positive. You say, what do you mean positive? Well, we're going over here now. See this? Where does that happen? That actually happens in 2 quadrants. So we're going to put everything together now. This is now meaningful. Let's put it all together. Where is cosine positive? Right? Cosine is positive. You say, why do you keep saying cosine's positive? They want to know where cosine is 1 over the square root of 2. It happens in quadrant 1. You say, why? Because in quadrant 1, okay, all of your trig ratios are positive, meaning sine, cosine, and tangent. What other quadrant is cosine positive? 4. This is why it's a C. All students take what? Calculus. So cosine is also positive in quadrant what? 4. So what that means here is a couple of things here. That pi over 4 now is a reference angle. If I rotate, ladies and gentlemen, remember this is 45 degrees. Remember that reference angle? They're saying this is pi over 4, 45 degrees. What positive angle from 0 to 2 pi does that represent? You say this is a quadrant 4 solution. How do you guys get all quadrant 4 solutions? You guys remember? I gave it to you this way. The angle theta will be what? 2 pi minus the what? Reference angle. Now that's good for what quadrant? Quadrant 4. I'm going to try to, I think I made a mistake by putting it way up here. I'm going to put it down here. And I'm not sure what color that is. Okay. So the angle theta here will be 2 pi minus the reference angle. That's the theta they're talking about here because the answer has to be what? Between 0 and 2 pi. Now, you say, well, there is no theta. I know x is 2 pi minus that same reference angle. This is the reference angle. They just changed the letter. It's pi over 4. So the second solution will be 2 pi minus what? And then we're with the arithmetic we've been seeing for quite some time. If the denominator down here is what? 4. What do you guys do? 4 over 4. What does that give you? 8 pi over 4 minus pi over 4 gives you what? So the second solution, ladies and gentlemen, is 7 pi over 4. So sometimes, I'm going to put this here and summarize this here, okay? This is known as the first solution, pi over 4. This is known as the what? Second solution. They put a little subscript. That's x sub 2. So there's two solutions here from 0 to 2 pi. Let me move that. You got two solutions. The first solution is what? Pi over 4. The second solution will be what? 7 pi over 4. And you might say, do I have to find all solutions? Yes. And there you go. Easy peasy, lemon what? Lemon squeezy. Yes.
So would we put it down like x1 as the first solution and then x2 as the second solution?
Yep. X1 and X2. Absolutely. Now, I'm going to give you guys a note here. Let's do a note here because you might say to me, hey, Mr. Judge, I studied for the last test and I'm right in here. Let's say it's the last test. And I use the inverse. Remember the inverse? You can do that. You studied for that. You earned it. But you still have to be awake. So the price you pay for using your calculator, and put that in the notes, is to be awake, to be knowledgeable, meaning second inverse cosine now of what? 1 divided by the square root of what? 2. Move that out. Close that. What do you end up with? What does it say? Does that say 45 degrees? That sounds about right, but what's the problem? Everybody know what the problem is? You might say there is no problem. And I'll say you're right, there is no problem. But it only gives you one solution. So you might say, well, what do I do then? You get the other solution. You go, well, how do I get the other solution? All students take what? Calculus. That's what you use. So you're going to have to pick your what? You're going to have to pick your poison. Meaning, you're going to have to use the skills we studied and worked on. There's a reason why we worked on all of these things. You're looking at the reason right now. So all that detail, ladies and gentlemen, you're going to have to find the second solution. The second solution is going to be 7 pi over what? 4. There it is.
So how do we get it again? I mean, I know we didn't get it on the calculator, but like,
How do you get it again?
I mean,
Watch the video again. It pays to be what? Awake. So there you go, ladies and gentlemen. Easy peasy what? Lemon squeezy. So now, if I said to you, maybe they give you this. See if you're awake with this one, right? Do you guys like X or you like theta? It doesn't really matter. Let's say they get cotangent theta plus 1 equals 0. Is this a trig equation? Yes. What do you guys want to do? What do you always do first? Don't you first solve for cotangent? Okay, how do you do that? Cotangent theta is what? -1. You guys have some skills. What did you guys work on? Oh. What's the reciprocal of cotangent? So if I said to you, we're going to use the reciprocal. Tangent theta will be 1 over -1. What does that mean? Tangent theta is negative what? 1. Okay. All right. Now, here's what I'm going to say. You're going to use the what? TI calculator. We're going to kind of go back to the last question because the TI calculator isn't going to give you all the answers. And you go, oh my God, the TI is not going to give me everything? No. So how do we find the inverse? You guys remember? Because we're going to use the calculator. You guys seen this on the test. What was it? Theta will be what? The inverse tangent of -1. Is that true? Isn't that? If you're going to use the calculator, we're going to have to do the what? Use the inverse tangent. There you go. So let's try that out here. Second tangent, -1. What's your inverse tangent? What's theta going to be? You go, theta's -pi/4? But what is the problem again? What are they going to ask you for? Your solution, and they didn't put it down, but let's put it down here. They're going to say theta has to be between what? 0 and 2 pi. And you go, oh no. Can I just leave it like this? No. They want to know what is theta between 0 and what? 2 pi. So does anybody have an idea? What should we do? How do we find? This is -pi/4. I mean, how do we begin to go about getting our solutions from 0 to 2 pi? What's coterminal to -pi/4? What do you have to do? I'm going to even write that in my notes. How do you find the coterminal angle? What do you guys do? You remember what you have to do? You have to add what? 2 pi or 360 degrees. Is that right? So then you're going to do some arithmetic. What do I mean by that? If that denominator is 4, what do? You multiply the top and bottom by what? 4. Is that right? You guys see that there? 4 and 4. What do you guys end up with? That's going to be what? -pi/4 plus what? 8pi/4. Is that right? Does anybody know what's this going to give you? Ah. Is that true? All right. There's an answer. But what's the story now? Go back. We're going to have to go to this idea that all students take calculus. Because, ladies and gentlemen, you may not have only one answer. Okay? You say, what do you mean by that? Well, -pi/4, by the way, you got to put all these ideas together. See, some people just think, I'm just going to use my technology. Just use the calculator. That does everything for you. Well, no, it doesn't. So if I said to you guys here, this is that angle. If you looked at it this way, if you said that solution by the TI is the angle negative pi over 4. Is that right? However, you just found as a positive angle that that's really what? 7 pi over 4. Is that true? But what else do you guys know? Tangent, they're saying over here, tangent is what? Is negative. Is that true? We're using the TI. We're using our technology. You may like using technology, but notice it doesn't give you everything you need to know. And that's the point. So notice what you had to do, ladies and gentlemen. You had to what? You had to find the angle, 7 pi over 4. You had to find coterminal angles. Oh, right. Tangent's negative in what quadrants? Do you guys know? All students take calculus in quadrant 2, not in quadrant 3, quadrant 4. We have the quadrant 4 answer. So the question's going to be, what is the quadrant 2 version? Because there's 2 quadrants where tangent's what? Negative. There's 2 quadrants, not 1. How do you get the other quadrant? It's a mystery. These are the problem-solving skills you guys have to have. Well, what quadrant is it in? Is it quadrant 2? Okay. Do you guys remember that? How do you get any angle in quadrant 2? Remember I gave this to you? What do we know? A quadrant 2 angle, I can tell you where it's at. It's going to be right here. Okay? Now you say, well, how do I get that? Really simple. Any quadrant 2 angle is going to be pi minus the what? Reference angle. Do you guys remember that equation? That's for quadrant 2. Pi minus the reference angle. Is that true? You say, well, what's the reference angle? Like, all of that information is back. I thought I got to use my calculator. Well, what's the reference angle? You guys are looking at it. The reference angle is right here. It's pi over 4. Is that right? Isn't that also known here as that reference angle? Here and over here? Is that true? Isn't that your reference angle? So the quadrant 2 angle will be pi minus what? Pi over 4. Do you guys have the, what's that denominator? Four over 4, what do you get? 4 pi over 4 minus what? Pi over 4. 3 pi over 4. So this here is going to be the what? The second solution? Is that right? Or the first? Doesn't matter which one you call them, second or first. So, ladies and gentlemen, this is going over every detail of what we worked with in this course. So even if you use the TI and you said, Mr. Judge, I like using the TI, I'll say, okay, that's good. That's really good. You can use it. That's great. However, the devil's in the details. The calculator is not going to give you every solution. That means you got to think about what's going on. Now, I'm going to give you guys a note here because we actually did this when we found exact values. You may say, what do you mean? Do you guys remember I did this to you guys? I said, you remember this? We have to find where tangent of your reference angle is positive. And this is going to be using the definition. This is opposite. Is it opposite? What is tangent? Do you guys remember? Opposite over adjacent. So you use the special triangle. So I'm sharing with you guys what you did in the past. The reference angle opposite over adjacent is what? Which triangle is that? That's a 45, 45, 90 degree special triangle. So the reference angle is pi over 4, just like we said it would be. But tangent is what? Negative. So I'm sharing with you guys everything we already did. Here it is. Pi over 4. So you might say, okay, tangent is negative in quadrant what again? Quadrant 2, quadrant what? 4. So, ladies and gentlemen, this is again my point to you. What you guys did in the past, this is the reference angle. This is your reference angle. What you may recall is how do you get your answers for the various quadrants. Quadrant 2 solutions, you remember these equations? That was going to be pi minus the reference for quadrant 2, and for quadrant 4, the angle is going to be 2 pi minus the reference. Is that true? So you said, okay, here's my first angle theta. If the reference is pi over 4, you plug in pi over 4. And like we already got, that first angle will be 3 pi over 4. We already did the arithmetic. Check your notes. And like we did before, we already did the arithmetic. If the reference here is pi over 4, the second solution will be 7 pi over 4. Check your notes. We already did the what? Arithmetic. So this is how we get the two solutions, ladies and gentlemen. And by the way, so here's the first solution, and then we'll get the second solution here. Oops, come on. First theta, here's the second theta. Note the relationship here. That's pi, right? There you go, ladies and gentlemen. Easy peasy lemon squeezy. Yes. What's that? Reciprocals. Cotangent became tangent because what identity was that? Aren't these reciprocals? Yep. These are reciprocals. You guys remember that? And that's what you guys want to do. So I showed you two ways to do both of them. One is by using your calculator, like you already had a test on. But don't think because you get to use your calculator, you're going to get all these answers. No, if they give you 0 to 2 pi, they want the answers to be 0 to 2 pi. You got to go back and find the coterminal angle. And once you find the coterminal angle, you have to find the other solution. There's two. And these angles are going to be differ by 180 degrees, by the way. Notice that. That's an important detail. So all the details here to find these solutions are what you're looking at, ladies and gentlemen. Now, I'm going to have you guys try them. They can say solve for x or solve for theta over the interval from 0 to what? 2 pi.
What is a negative angle? You're gonna have to find the two answers because you don't really have those. When it's a positive angle.
Positive angles have two answers. Negative angles have two answers.
But like it's not given to you at the beginning, I guess, the negative answer. I mean the answer for the negative angle. You gotta find two. And find a coterminal.
Well, I'm going to break the news to you guys. It doesn't matter if it's positive or negative, because with your 4 quadrants, all students take calculus with all 4 quadrants. Even if it's positive, there's 2 solutions. If it's negative, there's 2 what? Solutions. So there's always going to be those 2 solutions there.
But like the solution for the negative angle isn't given like right away, like with the positive solution, like the positive angle. Theta.
How about cosine theta? Okay, we're going to have these here. We'll see what you guys get. Yes, our audio is now on. Okay, so we're first going to have to solve for this sine theta. Is that right? So what do? Subtract 1. You get 2 sine theta is -1. Okay, what do you guys do now? You can divide both sides by 2. And now you have what? Sine theta is negative what? 1/2. Now, here's going to be my point to you. You're going to have to pick and choose which route you go. What am I saying by that? You got to choose, you got to pick your poison, ladies and gentlemen. What do I mean by the poison? Are you going to use your TI? Or are you going to use special triangles? There's no third option. There's only 2. You can't figure it out by graphing. So which choice do you guys want to use? You got to pick your what? Poison. You go pick my poison? Okay. Wow, I guess let's use the reference. Is that right? So if you're going to try to find that reference angle, it's going to be a special triangle here. That is going to be a positive angle because, again, the reference angle, ladies and gentlemen, is a positive quadrant 1 angle, right? So you're going to have to now remember, what's the definition of sine? Opposite over hypotenuse. Okay. The opposite side is 1. The hypotenuse is 2. What's the adjacent side? Good. What is that reference angle going to be? What special triangle is this? The 30, 60, what? 90-degree special triangle. So, the reference angle must be what? Isn't it 30 degrees? Is that 30 or is that 60? That's 30, so it's pi over what? Is that true? You guys know how I know? Sorry, here's 1 and here's 2. So that's half of 60. So this whole thing would be 60 degrees. And that doesn't look like a triangle, but okay. There is your what? That's the reference angle. Okay? Sine is positive. This is a quadrant 1 angle. I'll show you what I mean by doing what? Let's bring in what? Where's our picture here? All students take what? Calculus. So this would be, what angle is that again? 30 degrees, right? So here's my point to you. You know how sine is positive, right? This is your reference quadrant. So that one angle, that 30-degree angle, that's your reference angle right here. This is that whole point of reference.
How do we get 1/2 from negative 1/2 over 2? Wait, 1/2. Sorry.
When you look for the reference angle, it's always the positive what?
Oh, yeah.
Quadrant 1 angle. So, but you have to go back and say, oh, but wait a minute. They want sine of negative 1/2, not positive 1/2. There's 2 quadrants. Sine is negative in quadrants what? All students take calculus. So in quadrants what? 3 and quadrants what? 4. You just have to remember now what's the formula for both? You say, what do you mean? Well, how do you find an angle in quadrant 3? That's theta equals pi plus the reference, and an angle in quadrant 4, theta is 2 pi minus your reference angle. So quadrant 2 and quadrant 3 is the angle they're looking for. You found the reference of pi over 6. So you're going to do your arithmetic now on this here. So now here, ladies and gentlemen, here's your arithmetic. You take pi plus pi over 6, and you take what? 2 pi minus pi over 6. Do you guys remember how to do that arithmetic? Right? You guys remember we were working on this? Finding exact values. So what do we do with the first calculation? Don't I take this 6 times 6 here? And over here it's 6 times 6 as well. So that your first solution will be 6 pi plus pi over 6 pi over 6. Maybe we need to see all this first. You see that 6 pi over 6 plus your pi over 6. And here this is 12 pi over 6 minus your pi over 6. So what is your solution? Your first solution is going to be what? Second solution is going to be what? What is this? 7 pi over 6. And then, what's this one? There's your two answers.
And you said it doesn't matter what order the solutions are.
No. What you call theta 1, if you switch the order, it's fine. But I just went in order of quadrant 3, quadrant 4. Now, again, these two quadrants are where sine is what? Negative. Remember, this is your reference angle here. That's the pi over 6. This is your reference angle here. This is pi over what? 6. So getting that reference angle, which is always the positive angle, this is why you always set it to what? Positive, and why you always call this the reference angle. Why it's positive, even though the original question is, where is sine negative? Well, you first have to get that quadrant 1 answer. You always get that quadrant 1, and then you could get the negative sign answers because you're going to use these particular formulas. So I would recommend you put that in your what? In your notes, because in quadrant 1, you say, what's the formula for quadrant 1? Well, it's the angle is the reference angle, if I can get the right tool. And then in quadrant 2, even though we gave you guys that already, the quadrant 2 is going to be pi minus the what? Reference. So you're going to need to really make sure you guys are aware of what? Those quadrant formulas. They're all based on you finding what angle? What's this known as? The reference angle. And you can't do anything without getting this what? Reference angle in purple. This is why I'm always going to use purple for it. Always, always what? Always. So we're going to actually solve, ladies and gentlemen, tomorrow, the other what? The other two. But at least you could get started. Next we'll have a final, and we'll have test 4, and solving trig equations will be on both. Okay, so we have to solve some what? Trig equations now. All right, so ladies and gentlemen, let's go back to where we left off. What do you guys think? Right, remember, we're trying to solve trig equations, and at first they're going to say to you, let the angle theta be between 0 and 2 pi. So I want you guys to note here What in the world does that really mean? It means theta is in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Okay, so that's what that means. It means theta is in these quadrants. All right, so this is exactly what that means. Now, so this is kind of where we were working on yesterday, don't you think? All right, you guys remember this stuff from yesterday? See if I can try to fit that in. Okay, you guys can see all that right there. Now, I want you guys to remember this because this is the most important thing here. All students take calculus. This is what they mean by your answers being in every one of these quadrants, right? So you're going to rotate a positive theta, 0 to 2 pi, okay? Okay, 0 to what? 2 pi, 0 to what? 2 pi, 0 to 2 pi. So, ladies and gentlemen, I want you guys to understand all students take calculus. What that means is it tells you which quadrants these trig ratios are positive, okay? And so you're always going to have 2 quadrants where a trig ratio will be positive and 2 quadrants where a trig ratio will be what? Negative, okay? You guys okay with that? So sometimes people, they go, oh, I only want to deal with only 1 quadrant. No, there's going to be 2. So if you remember from yesterday, you go, wow, there's 2 quadrants. Yes, there's always 2 quadrants, okay? And how you really do this is quadrant 1 again is your reference quadrant, right? And I don't like how it just, there we go. You see this quadrant 1? This is your what? Reference quadrant where you get the reference angle. Okay? Quadrant 1 is always the what? Reference quadrant where you get the reference angle. And in quadrant 1, I'm going to give you the equations. Theta is equal to the reference quadrant. That's in quadrant 1. And so, okay, and that's going to be where all the trig functions are what? Positive again. Okay. And then, to remind you, if you have an angle in quadrant 2, the equation you use will be what? What's the equation? You guys remember? It's going to be what? Theta will be pi minus the what? Minus the reference angle. So you always need that what? Reference angle. And again, you say, well, what happens with or if my angle is in quadrant 3? Well, what's the equation you use to get the answer? Theta now will be pi what? Plus. Good. This is the key. You're not going to get any answers without these equations, ladies and gentlemen. Okay, let's go back there. All right, you guys see my point? So you need these equations. Now, what if your answer is a quadrant 3? Or I should say your angle is in quadrant 3. How do you get your answer? We got to get some coffee in us. Theta will be what? 2 pi minus the reference. Good. So, like I said, the name of the game is getting that reference angle. And this is where most of the questions will involve your special triangles. This is where most of them, not all. So this is where that special triangle information comes in. So, ladies and gentlemen, you know, there's ways we can solve this. Okay, and so remember what we discovered yesterday? We said, okay, start by doing what? Solving for cosine, right? So by adding 1 to both sides, what do you end up getting? Cosine theta equals 1. Now be careful here. Right? Didn't I get through saying to you most of your answers are going to involve a special triangle? But not all. You go, really? What do you mean not all? Well, even if you try to do a special triangle here, right? And you put the ratio 1 over 1, what's the definition? This is 1, this is 1, and then you go, I don't know what this is. There is no what? Special triangle here, all right? And you go, oh no, there's no special triangle that fits that description. Because you only have 2. There's only 45, 45, 90, 30, 60, 90. There's only going to be 2. So you go, okay, since there's only 2, what do I do? Right? You guys know what I'm saying? So when I'm going to go back, and I'm going to say this to you guys here. What I have done in my life, I think I got rid of what I'm looking for. When I personally think of this question here, what I think of, ladies and gentlemen, is what does the graph of cosine look? I spent a lot of time studying cosines and graphing. You might as well use that. Is that true? You say, I spent time doing this. And if I were you, I would think about this. Because it's very what? Useful. So remember, cosine starts at 1, and it does what? It goes down to the intercept, the minimum value, back at the intercept, and then at the maximum value. And did I think I did it. Let's get some more coffee. Here's theta, and here's y, okay? So if you said to me, hey, Mr. Judge, where is cosine 1? Well, there's 2 values of cosine being 1. What are they? Remember, this is 0, right? So that happens when theta equals 0 degrees or 0 radians. That also happens when theta equals what? 2 pi. You say, how do we know? Because it's right here. So theta is 0, and theta is what? 2 pi. And it all comes from the fact that cosine is a maximum for those values of theta. It comes from the graph, ladies and gentlemen. So I don't have to do any special triangles. I am done because my solution has to be between 0 and what? 2 pi. Did I screw up on this one? Is this 3? Or I'm sorry. Oh, we didn't do 2. I'm sorry. Is this 3? Yeah. All right. Well, we did 3 before 2. Okay, good. Sorry. See, we do need that coffee. But we went out of order. We did 3, and ladies and gentlemen, we're going to do 2. But here's a kind of a very interesting question. This is why I say some of the questions involve special triangles and some don't. And so this is one where you got to go back to the curve. At least I do, and it's very simple, and I'm done. The curve gives you 1,000 what? A picture gives you 1,000 answers. You say, what do you mean? Well, let me note. I'm going to give you guys a note just so you guys can understand my point with the curve. Let's make this a nice teaching moment. What if the equation is where's cosine theta 0? Right? What if we have to solve cosine being 0? What does that even mean? They're just asking for the intercepts. They're saying, okay, I know when that happens. That happens when theta is what? Pi over 2. Or theta is what? 3 pi over 2. Ladies and gentlemen, you're done. Okay, this is finding the intercept. So I just want to kind of share with you guys that. Just as a note, because we're looking at the curve. And then you say, what's another note? Well, let's give you guys another note. What if the question is, where is cosine theta equal to -1 now? You go, cosine theta can be -1? Yes. Where is it? Here's where -1 is. Isn't it right here? So if I said to you, cosine theta is -1 for what value of theta? It's pi, isn't that right? Because this is where -1 is. So, ladies and gentlemen, theta here is going to be what? Pi now. So, folks, there it is for number 3. And there you go. So I just want to point out those observations. Now go back to number 2. You go, okay, Mr. Judge, what are you talking about for number 2? Okay. Let's do this one here. So as you solve again, and I'm going to try to bring everything else here down eventually, but okay. As we solve for tangent, remember you do that first? Right, we talked about that yesterday. You first solve for this. Solve for tangent first. And when you do that, what do you guys get? Don't you get what? If I subtract 1 from both sides, right? You get tangent theta is -1. And then what do? Divide both sides by square root of 3. So you get tangent theta is -1 over what? Square root of 3. And now you're in the situation where I want to remind you here, again, this is a negative value. When you're looking for the reference, you're going to now look for the quadrant 1 solution. You're going to use that reference angle. That's a positive what? Angle. So this is where the reference starts to come in because you're going to have a special triangle. All right, you guys okay with that? All right, so then if I ask you, what in the world, how do you get that? What is that? Remember this? What's that definition? Opposite over what? So what is the opposite? And what's the adjacent side? What does that mean? Hypotenuse is 2. What's the special triangle? It's a 30, 60, 90 degree special triangle. So ladies and gentlemen, and the angle, what's the angle going to be? It's 30 degrees, is that right? You go, how do you know? You know how I know? I know where it comes from. This is 1, this is 2. This is supposed to be 60 degrees. This is 60 degrees. 60 degrees. So you are bisecting, cutting in half. So it's 30 degrees here. So, ladies and gentlemen, what we did that first week is still there. This is what we did the first week. Okay, pi over 6. Now you go back and you say, what was all this stuff about, right? What do I do here? Okay. So you go, oh, we got to know where tangent is what? Negative. What did I always say? Or not always say. What did I just say earlier? There's going to be 2 quadrants. There's always 2 what? Quadrants. Can I say that again? How many quadrants? 2. So don't go, oh, okay. Only 1. No, what quadrants are there? Now we have to go back here. Oh. Don't know what happened. There's my reference quadrant, right? What 2 quadrants are there? Where's tangent negative? It's going to be quadrant 2 and quadrant 4. Yes, 2 and 4. Why? Why is tangent negative in quadrant 2 and 4? Because the meaning of all students, right, take calculus. This means all 3 trig functions are positive. This means sine is positive. So in quadrant 2, cosine and tangent are negative. This means tangent's positive. And this means cosine's positive. So it means sine and tangent are what? Negative. So ladies and gentlemen, it goes back to the meaning. Do you know what all students take calculus means? And so we're going to look for 2 angles. The first one's going to be in quadrant what? 2. It's a quadrant 2 answer. And theta is what we're looking for. And this is why I just put that ray. We rotate, if I can place it, right? We rotate this ray where? To quadrant 2. You with me on that? What's the reference angle again? Pi over what? Was it pi over 6? So what kind of arithmetic do I have to do, right? My first answer is pi minus pi over 6. What's going to happen now? See that here? Put that over 1. So what are you going to use? Good job. You guys see, how long have we seen that arithmetic? Since the beginning. Okay, so what's your answer going to be? 5 pi over 6. And that's your first solution. However, you might say, how do I get the other solution? Okay? The other solution, ladies and gentlemen, is a quadrant 4. Now, since my reference angle is pi over 6, right? You're going to do the arithmetic, meaning the second solution I call theta 2, is 2 pi minus pi over 6. Do your what again? Arithmetic. Good. What is it going to be? 6 times 6 times. You say, why use the 6? This is the number down here that helps you. So, ladies and gentlemen, theta 2 is going to be what now? Good. 12 pi over 6 minus what? And that's going to give you what? 11 pi over 6. Let's close the door if we can. Okay, let's close the door. I don't know. So I want you guys to understand there's two answers for theta, and that's why they always say to you, at least in the beginning, they want you to understand how to do this from 0 to what? To 2 pi. Okay, so this is their approach now, 0 to 2 pi. And what that does for us, I'm looking for your textbook here. It gives us a nice way to do what? Find these two solutions. Now, ladies and gentlemen, here's what they're going to do. They're going to kick things up a little bit. Right? So you say, how are they going to kick this stuff up? Well, they can say here is 4 sine squared theta minus 1 equals 0. Okay? So here's what we call a little bit of a kick up for you. And you might say, well, what's going on here? Well, what they did is they gave you a power of 2. You guys okay with that? So let's see how we're going to approach this. We're going to approach it the same way. Right? We're going to first do what? Solve for sine squared theta. So you say, how do I do that? You're going to say what? This is going to be what? 4 sine squared theta is 0 plus 1, which is 1. You're going to divide both sides by 4. Sine squared theta equals what? 1/4. Now, what are we going to do? Here's the big question. We're going to have to solve for sine theta. That's sine squared. Remember, that's the first thing you always do. You want to get that trig function. How do you do that? Does anybody know? Yes. What do you guys use? Use the square root formula. You're going to go back to that algebra. You go, oh my gosh, algebra. If x squared equals n, the square root formula says x will be what? Plus or minus the square root of n, the square root formula. So that means sine theta will be plus or minus square root of what number here? Do you guys see this here? The square root of 1/4. And now here, you say, what do I do with this? What's the square root of 1/4? It's 1/2. Say, how do you guys know that's 1/2? Well, go back to, I don't know, intermediate algebra, square root of 1, square root of 4, that's 1 over 2. So, bless you. Sine theta is now going to be plus or minus 1/2. Okay? So you now have to say, well, what does that even mean? Well, it means two things. It means sine theta is what? Positive 1/2, and it means sine theta is negative what? 1/2. So there's going to be, wow. Two cases to consider. Where sine theta is positive 1/2, and where sine theta is what? Negative 1/2. Is that true? And so the question is going to be, what's going on here with this one? Huh? Well, remember this. I'm going to just remind you guys here. You're going to have two quadrants. Remember that? And here you're going to have two what? Quadrants. Because again, they want theta to be what? Between 0 and what? 2 pi. So let's go back to the reference angle. The quadrant 1 answer, because this is our process. You go, okay, what's the process? Here's the process. What's the definition of sine? Okay, so opposite is what? 1. The hypotenuse is 2. Is that true? What does it mean the adjacent side has to be? Square root of 3. Is that right? And you go, wait a minute. There is a special triangle. Which one was it? 30, 60, 90. Is that right? So in this case now, your angle theta will be what? Is that 30? Pi over 6. Theta was 30 degrees. We actually seen that in the last what? That was in the last. It's the same special triangle. 30 degrees again. Is that right? So I told you guys you're going to see this special triangle over and over again at times. These two. So, all right, you go, okay, I got 30 degrees, but now let's remember, if we go back here, and I think I might be able to still paste it. I don't know, did I copy it? I might have. I want you guys to remember this. Let's erase some of that, okay? For the sign being positive in gold, I'm going to color this gold now, okay? Or brown, whatever color that is. I'm colorblind. This is where sign is positive. Is that true? Because it's positive 1/2. Which quadrants is sign positive? It's the first and the second. You guys with me on that? So you might say, okay, believe it or not, you already have the answer for the first. Was it 30 degrees again? Right? See that there? 30 degrees, because that's what the reference angle is. In quadrant 1, the angle is the reference angle, so that's 30 degrees. So far, your first solution, pi over 6, which is 30 degrees. Now, what's the second solution? You might say, what do I do? Well, plug in that reference of pi over 6. Do the same arithmetic, And the last example, we found it to be 5 pi over 6. So these two solutions are associated with what? The sign being what? Positive. You guys remember that? It's the second solution now. This is for sine being 1/2. Those are the two solutions. That's why I colored it gold. The fact that you also have sine being what? Negative, because this is plus or minus. We got to consider this. Where is sine negative? The last two quadrants. So you go, oh, okay, I see that. Sine's negative where? Quadrant 3, quadrant 4. So we have to get the quadrant 3, quadrant 4 solutions now. We got to get these last two, what? Yeah, if I can get that in there. So I'm going to, picture is worth 1,000 words. So you guys can see, these are all the solutions. So the quadrant 3 now, plug in your reference of pi over 6. And now you got to do that arithmetic. The third angle, pi plus pi over 6. The good news is we have seen this arithmetic over and what? Over again. So this will give you 6 pi over 6 plus pi over 6, which gives you what? And you're done. So I think I'm going to put it down here. I'm just going to say the third solution will be what? 7 pi over 6. Now we got to get the fourth solution here. And you might say, well, how do we get that fourth solution? Well, we got to do this arithmetic. We got to plug in for the reference pi over 6. So it's 2 pi minus pi over 6. Twelve pi over 6 minus what? Which gives you, what's the fourth solution? It's 11 pi over 6. So, ladies and gentlemen, there is going to be a little bit of algebra again for some of these kind of questions, just to share that with you guys. A little bit of algebra. And that's one of the situations that comes up. All right, you guys have any questions? And so those are all the gory what? Details, but it goes back to, can you solve some of those? And let me do another here. Secant squared theta minus 4 is 0. Should we give you some few minutes to get this started on your own? Let me do this here to let you guys remember. Well, let's do this here together at least. See this here? We're going to have to solve for this first. Remember that? So that means secant squared theta, if we add that 4 to both sides, will be 4. Now, you might say, Mr. Judge, what do I do with this? I'm going to say to you, use the reciprocal. Convert this equation to one that has what? Cosine squared. You say, well, what does that even mean? That means cosine squared theta, ladies and gentlemen, will equal what? 1/4. You say, why 1/4? Because the reciprocal of 4 is 1/4. Okay? So here's cosine squared theta. Yeah. If it's cotangent, convert it to tangent. Absolutely. And, maybe we'll find someone or find one and we'll look at that. But, all right, ladies and gentlemen, I'm going to give you guys a few minutes to try this out, see what you get to finish this one off. But this one's similar. It's very similar to the one we just did. So you guys have a little bit of skill sets. We'll give you guys time. All right, let's try this out here. Okay, you guys ready? At this point, what do you guys remember? What do you guys use again? Just use the square root formula just like last time. And by that square root formula, you get cosine of what? Theta plus or minus square root of 1/4. And now, square root of 1/4 becomes what? 1/2. And that means two things again. That means cosine theta is what? Positive 1/2. And it means cosine theta will be what? Okay, so the second you have this, there's going to be what? 4 solutions. Okay, there's going to be a total of 4 what? Solutions. And you might say, why? Because cosine theta being positive will give you 2. And then cosine theta being negative will give you the other 2. You guys okay with that? You guys see my point? Easy peasy lemon squeezy. You see the point? So you're going to go straight to, again, the reference information. All right. Now, I mean, if you wanted, do you guys want to go use the reference again, or do you guys want to use the calculator? Reference? Okay. All right. I don't blame you. Okay. Reference angle. What's the definition of cosine? It's adjacent over what? Hypotenuse. Okay. So the adjacent side is 1, the hypotenuse is 2. That means the opposite side is a square root of 3. And I recognize this situation. That is a special triangle. Which one is it? 30, 60, 90 again? Okay. So what does that mean about your angle? Theta is going to be 60 degrees or pi over what? There's your reference, pi over 3. All right. So, yeah. And then I do think I probably still have. Yes, I do. And let's get rid of more of this distraction. See my point? Pi over 3. Anyway, all right. Okay, so let me do something here.
So essentially we're gonna have positive pi over 3 and negative pi over 3.
Well, what you're going to do here is this. Let's go back. Remember, cosine is positive now in what quadrants? Let me get rid of this. Where is cosine positive? I'll put that in gold. It's going to be where? Quadrant 1 and 4. We already know, if I keep that color here, that reference angle is 60. Is that true? That's our first solution. So theta 1, 60 is pi over 3. What is your theta 2? You guys know what theta 2 is going to be? You're going to say, do I put pi over 3 here? Sure. So theta 2, 2 pi minus pi over 3. What does that mean now? Remember, our arithmetic is going to be now what? Multiplied by 3. There's a 1 there. Multiplied by 3 again. So the second positive solution will be 6 pi over 3 minus pi over 3. And that second solution will be pi over 3. So I want to make sure people understand. See, that was at 60 degrees. Okay, so this is going to be actually 300 degrees. So you guys know. I'm trying to draw an arrow, and sometimes it's not. There we go. So these are the two positive solutions. So the negative solutions, where is cosine negative? Quadrant 2. Quadrant what? 3. So, okay, 60, you're going to find it to be 120 and 240, it looks like. So there's going to be 4 solutions, but plug in the reference everywhere. Pi over 3. What's this? Pi over 3. You're going to have to do some more arithmetic now. So for this first one, you want pi minus pi over 3. Is that right? So theta 3, pi minus pi over 3. Put that over 1, ladies and gentlemen. 3, and then what goes on here? 3 times 3. theta 3 is going to be what? 3 pi over 3 minus pi over 3, which will give you 2 pi over 3. So then this last is pi plus pi over 3. Is that right? So now you just do pi plus pi over 3. And so, ladies and gentlemen, theta 4 by the arithmetic, pi plus pi over 3 over 1, multiply top and bottom by 3. And you should be good to go there. And so theta 4, 3 pi over 3 plus pi over 3, which gives you what? 4 pi over 3. So we'll say 4 pi over 3 over here. And ladies and gentlemen, easy peasy, lemon what? Squeezy. This is your 4 solutions here. Okay, 4 solutions. So, they're going to have you do a little bit of algebra here with some of these questions. And just, sorry, just looking at your book, I apologize. I'm going to look at they have something like this. Three tangent squared is tangent now. And then you might say, well, what kind of algebra are they going to do here? Right? So there's a lot of ways you can try to show people something like, I just want you guys to recall or to note, when you had equations like this, 3x squared equals x, if you guys remember that, right? How did you guys solve that in algebra? Let's go back. What you had to do is subtract x from both sides. Had 3x squared minus x equals 0. So what you had to do now, ladies and gentlemen, if you guys remember, is you had to factor out what? Yeah, the greatest common factor, which will be x. And so back in the day, you said, I'm going to factor out x. That leaves you with 3x minus 1, and that equals 0. And what did you guys do back in the day? How did you guys solve this? You had to use what was called the zero product rule. X is 0. 3x minus 1 is 0. And this means 3x is 1, or x is being 1/3. So do you guys remember the algebra back in the day? You guys remember this? So you got solutions. Now, you might say, well, what does that have to do with this? Well, what you can do is let that x be tangent. This is called a substitution. And I don't even know what color. Let's use pink. How's that? And so you already did the algebra. You say, what is x? X is tangent right here. So that's why we got this nice equation here that we solved. And since x is tangent, we already solved it. What that means is tangent theta equals 0, and that means tangent theta equals 1/3. And you say, why? Because x was tangent. So wherever there's an x, replace it with a tangent. So you go back to algebra, you do what's called a substitution. This is a substitution of your variable. And the book might use the letter T. They'll use like a T instead, not X, whatever. Fine. I went back to X because of algebra. So here's some of the algebra that's there. This is why algebra used to be a prerequisite, okay? It still is. So here's tangent theta is 0, ladies and gentlemen. We already have that. So we're going to have to go back and understand the fact that they want all solutions to be 0 and 2 pi for now, okay? They want your solutions to be here, is it between 0 and 2 pi. So focus on this first situation. I'm going to call that situation number 1, I guess. I don't know. Let's focus on tangent theta being 0. Where are your solutions for tangent theta being 0? Anybody know? Something should stand out to you. Yeah, there is no special triangle. Because there's no special triangle, go back to your tangent picture. This is how I deduced my answers here. Look, I spend a lot of time graphing in my life, right? I might as well use those skills. Isn't that the tangent curve? So where is tangent theta 0? It's where? Here. But you guys remember about tangent, though? What's the deal with tangent? What's going on with tangent? Tangent, that domain is between negative pi over 2, positive pi over 2. Your solutions have to be where? There's different solutions for tangent. Do you guys remember? Okay. Tangent, remember this idea, is periodic. What does that mean? This curve will go on forever. This is only one, what? One cycle. What's the period of tangent? Anybody know the period of tangent here? Isn't it pi? We had a test on that. I guess that's why we have tests. All right. Now, what does this actually mean then, ladies and gentlemen? You guys know what this means? Since tangent is periodic, this behavior will occur over and over and over again. Come on, Desmos. You don't believe me? Periodic. This is only where tangent is 0. This is tangent is what over here? Pi. This is tangent is what? 2 pi. You guys with me on that? So from the interval from 0 to 2 pi, if I said to you, consider tangent over that interval, I guess I did theta. That's why it's confused. Now it's not confused. Okay? This is where 0 is. This is where pi is. This is where 2 pi is. So what I'm actually saying to you is we're going to use all that information. I'm going to even bring that in because I like that stuff. Look at that. Man. Are you kidding me? So you might say, well, how do I do this if I don't have decimals? You know what you guys do? What do you do? What does that periodic mean? Period being pi. If I take 0 degrees and I add pi, right? Here's my first solution. How do I get the second solution? 0 plus pi is pi. There's your second solution. How do we get the third solution? Take pi and add the period. Okay, you're adding the period here. And so the third solution is now going to be what? 2 pi. And you say, Mr. Judge, when do I stop? You stop here. Why? They want thetas from 0 to 2 pi. So ladies and gentlemen, this is where you stop. So for tangent being 0, we got theta is pi. Second solution, theta is, 0. Your second solution, theta is pi. Third solution, theta is what? 2 pi. This is how you do it. Now, you have to deal with tangent being what? 1/3 now. You go, how do we handle this? Go to the reference angle. There's 2 quadrants for positive tangent now. So you say, okay, tangent is what? Yeah, we got to draw a right triangle. Guess that helps. What's the definition? Do you guys remember? Opposite over adjacent. Okay, so the opposite side is 1. The adjacent side is 3. You know what that means about the hypotenuse? That's 2. What's the angle? What's the reference angle? Is that 30 degrees? Pi over 6. This is your reference angle. So, ladies and gentlemen, tangent's positive. We're dealing with the phrase that tangent theta is what? 1/3. So tangent theta is 1/3. Okay, it's positive. I guess I'm going to have to go back. All students take calculus. I'm going to erase this. How's that? Where's tangent? Now we're dealing with tangent. Where is tangent going to be positive? I'll erase all of this. Anybody know? Quadrant 1. Let's erase all of that. Tangent is positive right in here. Quadrant 1. And what was the answer we got? Is that 30 degrees? There you go. And that's where tangent's positive. It's going to be in quadrant 1 and in quadrant what? 3. I'm just going to share something interesting with you guys. I'm going to share it early now. Do you guys happen to know what's the relationship? So if that first angle, by the way, was 30 degrees, pi over 6, is that what we said? That first solution? Yes, I can use the reference information, but I want you guys to notice something here, okay? You guys see how these solutions are in opposite quadrants? This is directly opposite. Do you guys know what's the relationship between those two angles? Yeah, this is pi. Is that true? Do you know what that means I can do to get the second solution? Here's what it means. I can get that second solution by simply adding what? That pi. I want you guys to see that. That's a big deal. And I'm going to bring it down, because this is kind of like a point where we can even start to transition a little bit. And, you know, that's actually going to be, I could get rid of this. I want you guys, and get rid of this. I got rid of the reference angle. Once I get that first solution, you say, Mr. Judge, I can do that? If I notice that they're supplemental, that they're in opposite quadrants. Quadrant 1, Quadrant 2 are opposite, but they're directly opposite, meaning I can just simply add that pi, and you know what will happen for that second solution? It's 6 pi over 6, which gives you what? And those are the two solutions for tangent theta being 1/3. So, pi over 6, 7 pi over 6. So what we really can do now, we'll just simply say that's really our fourth solution and our what? Fifth solution. And this is where, I don't even know what color. Maybe we use gold. I don't know, but it doesn't matter. Right? This is where we got those two remaining answers. What do you guys think? There's 5 solutions here. So, ladies and gentlemen, we're going to do some more tomorrow, but I would recommend you guys getting started on your homework when? Yesterday. And this is now homework number what? 4. You guys with me on that? Homework number 4. Try those out. I did edit them, and I'll see you guys when? Tomorrow. Take care. Stay safe.